Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, does that robot have hooves? And how does that thing work? Hello everyone! Welcome to Robot Talk. I'm your host, Claire Asher, and I'm so excited to be back for Robot Talk Season 4, with new funding from the Hamlin Centre for Robotic Surgery at Imperial College London. Before we dive into the new season, I'd just like to say an enormous thank you to everyone who's supported the podcast over the last 3 years. It has been a pleasure and an honour to get to spend my time chatting to so many fascinating people from all different areas of robotics. I'm feeling refreshed after my summer break and I'm ready to talk robots. This week, we'll be returning to a topic that's very close to my heart, bio-inspired robots, to find out about how robot designs inspired by nature can help robots cope with uncertain environments, and even tackle some of society's biggest challenges. But first, I'm excited to announce that the Robot Talk t-shirt competition is back for a second year. For a chance to win your very own Robot Talk t-shirt, all you have to do is share your favourite episode of Robot Talk on social media and tag us at Robot Talk Pod. One lucky winner will be selected each month to receive an exclusive free organic cotton t-shirt. You can't get these gorgeous t-shirts anywhere else, so make sure you enter for a chance to win. So, with all that said, it's time for me to introduce this week's guest. I recently had a really interesting chat with Sara Adela Abad Guaman from University College London, all about adaptable robots inspired by nature. Today, I'm chatting to Sara Adela Abad Guaman, an assistant professor in robotics, control and autonomous systems at University College London, whose work takes inspiration from living organisms to develop robots with enhanced adaptability to variable environments. Hi, Sara. Wonderful to have you on the podcast.
Thank you very much, Claire, for the invitation, and I'm really happy to be part of this podcast.
So you're the head of the Adaptable Robotics Lab at UCL. Can you give us a bit of an overview of the research you and your group are working on?
Sure. The vision of my research is to use biological inspiration and morphological computation to enhance the adaptability and the performance of devices and robots as well. So I believe that the adaptability is intertwined with performance. For instance, an adaptable system is more likely to be used in several fields if it is capable to adapt to changing conditions. For instance, in nature, we have several examples of such adaptability, and that is the reason why I use bioinspiration as one of my vision. And the reason why I use morphological computation is because I believe that the body can play a role on contributing to this adaptability. And again, in nature, we have several examples of how the body can facilitate this adaptability. For instance, I am currently collaborating with the Haptics and Robotics Lab at UCL, where I have developed a haptic system, where haptics it is referred to the touch. So what it does is the system exploits the sensors in our skin, which are related to touch perception, in order to provide a more natural feedback. So what it does is it stimulates the sensors that we have in the skin, and this information is straight processed through the brain. So there is not an intermediary part that needs an extra computation in our brain to understand that touch feedback. Another example is developing a foot inspired on the mountain goats in order to enhance the adaptability of our robots to outdoor conditions. So in this case, I took inspiration from how the hoof of the goat is behaving, the morphology as well, the structure of the foot in order to develop a simplified version. And my aim is to enhance the adaptability of current robots for field application.
I love the idea of taking inspiration from mountain goats. When you see the foot of a mountain goat, you just think it doesn't look like it should be well adapted to that task. It seems very rigid. but they are incredible at what they do. So clearly they're doing something right.
And that is true. The thing is, like, if you look closer at the foot, in the case of the goats, they don't walk in the whole foot. They use only the tips. So what we see that is hard is the tips of the toes. But if you see farther, you see that there are compliant parts. So the other parts, the other joints are compliant enough to facilitate that adaptability. Additionally, in the foot, in the claw, at the bottom, there is a pad, which is also compliant, which increases the contact force with the terrain. And also this increases the contact area, which also makes them less prone to a slide.
Okay.
So basically what I did, I look into how each claw is moving. And for that, what I use is several information that we have of goats. There are lots of videos of goats climbing on almost vertical dams. They are climbing on trees. They also climb even steep cliffs. And that's their natural habitat. That's the way that they can avoid the predators as well. So the amount of time that the information needs to go from the tips of the toes to the brain is too much, because if it takes too long, the goat slides and dies. Yeah. So that's not something that goats want. And that's why I believe that the foot itself is doing the computation at the hoof level. And based on that, I look at the morphology, I look at how each toe is moving, and also I look at the tissue distribution. And with that, I develop a simplified version because, as you discussed with Helmut Hauser in your previous podcast, compliance is important. Softness is important to increase adaptability. But if it is too soft, actually, it might not be beneficial for the application that we're looking for. So, for instance, in this case, if you have a foot that is made of completely soft structure, it will not be able to bear the weight.
Yeah.
But if it is too rigid, it will not contribute to that adaptability. And that's why I also look how those soft tissues are distributed on the foot. And based on that, I developed this foot, this simplified version. And what I found is actually, depending on the compliance, the elasticity, the softness of this structure, the sliding force needed for making the foot slide is higher, can be higher.
Okay.
So when we ran the experiments, we found basically that the goats are moving inwards and upwards, the claws. And that reminds me something that I have seen in skiing. So when you ski, what happens? So you move inwards, the tip of the skis to brake, and you move outwards to gain speed.
Yeah.
So they are using a similar technique. And then if you extrapolate that to how our cars work, so the anti-lock brake system, what it does, it releases the brake and brakes in a periodic way. So what it does, it avoids losing control from the gearing system and also maximize the braking. And it does when the conditions are with high slippery. For instance, when the road is wet, when there is a lot of rain. And that is something similar used in the goats, actually. So what they are doing is they are moving inwards and outwards. So they are actually braking using the ABS system. And that's why at the end, the force needed to make them slide is higher. And so when they are in these hilly conditions, with their weight, they slide less with the hoof than if they don't have the hoof. So if they slide less, means that they are less prone to fall and die.
That's really interesting. I had no idea so much was going on in that small hoof. I guess the idea that's underpinning all of this is to be more adaptable to different environments. So where do you see this hoof being applied, this robotic goat's hoof?
Actually, the findings of this research can be adapted in several fields. For instance, it can be used in agriculture to enhance the adaptability of the robots to these changing conditions, because sometimes you have clay conditions, sometimes you have deformable soil conditions, and also, for instance, in wells, you have some mountains as well. So it can adapt to the different geographies that we have.
Yeah.
So we can use robots for this type of application. Another field where we can use these findings is in robots that are used for exploring other planets, for instance, Mars or the Moon, where you don't know what type of terrain they will have. They have to be able to adapt to sand, to rocky terrain conditions, and again, the hills are also another problem. And I believe that computation capabilities have evolved during the years enormously. However, the part that has not been developed is in the body of the robot. And for achieving a good performance, we need both. And I think that's why now there is this trend in order to enhance the body of the robot.
Yeah, definitely. So this is a really nice example of morphological computation, as you mentioned. And one thing I was thinking about that kind of concept is that obviously you've kind of mentioned that it means maybe you can have a quicker response. You don't have to wait for the signal to make it all the way to the brain and back again. But I guess it also means maybe you don't need as much computational power to achieve that same amount of adaptability.
Yes, that is true, because with the goat hoof, again, what we found is like the hoof, when it is a slide, before it slides, if you put a sensor at the tip, you can see that the vibration at the sensor is higher before it starts sliding.
Okay.
So what it is meaning, basically, if the robot, the main control of the robot, doesn't need to be constantly trying to adapt to each irregularity. It just has to take over that part when the hoof cannot do it by itself.
Yeah.
So that means that all that computation before it starts sliding is done by the hoof. And then the main controller can use that for doing other tasks which are more demanding, such as, for instance, computer vision.
Yeah. And I guess would be very helpful, if we were talking about exploring other planets where you don't necessarily have that much battery power, or you're constrained by weight or all kinds of other things that might mean you can't have the kind of the fastest, most optimal computer on board.
Yes, actually, that is true. Another particularity is that, as you mentioned, even if you don't have power, the foot still works.
Yeah.
That is something remarkable, because normally when I talk to some people and I ask, okay, what is your perception of a robot? And they say, oh, okay, it's a rigid structure, humanoid shape, or something like that. And then you think about it. So when it doesn't have power, so it stops working. It's like a rigid structure, that's all. But in our case, when we improve the body still can work in a parallel way, even without energy.
Yeah, that's such an interesting point. So, what else have you learned from biological organisms about how to make robots more adaptable in uncertain environments?
I have learned a lot of things. I mean, the main ones is that the body is key to enhance performance. For instance, let's go to the fingertip interface. First of all, you have to make it soft. So it has to be able to adapt to the different type of fingers. Otherwise, you will have to develop a fingertip interface for each user. So that is not useful.
Yeah.
And also, for instance, compliance, how elastic the body also is important. In the case of the fingertip interface, if it is too soft, the intensity of the stimulus change with the compliance, with the elasticity of the material. So that means that if it is too rigid, you need a higher in this case, it's pneumatically actuated. So you will need a higher internal pressure to apply a certain force than if you use a very, very elastic material. But in this way, what I'm trying to state is that sometimes it's not good to have either too loose or either too hard. Sometimes it's just a defined level that in a certain degree of compliance. So we have defined that a certain compliance level, that fingertip interface allows us to generate a signal that is slightly below the minimum threshold that humans need to feel a stimulus, and also a higher sensing range as well.
Okay, cool. Yeah, that's really interesting. So one of your goals is to apply robotics to address some key global challenges like climate change, biodiversity loss, sustainability. So how do you see robots and autonomous systems making a meaningful impact in these areas?
I mean, I think one of the main reasons why robots cannot be used or its use is limited is because of the limited adaptability that they have. And most of these global challenges are interrelated. So, for instance, if you go to climate change, it's related to biodiversity loss and also with sustainability. For instance, let's go to agriculture. So, what is happening now? Most of the production, food production for the world, is coming from developing countries. So, in developing countries, they mainly use hand labor, but unfortunately, because of climate change, now the temperatures are increasing. So that means people can work less hours on the field taking care of the crops. And if you have less people working outside, that means crops are going to produce less because weeds will start depleting the resources that were there for the crops. So at the end, the production loses. But at the end, we need to feed the population. So we need to find a way to produce food, but minimizing the impact that agriculture normally has in the planet. And for that, I see that robots can be used. In this case, leg robots needs to have a higher adaptability in order to be monitoring constantly crops, searching for weeds. And in that way, less chemicals can be used for controlling weeds, and also neighboring ecosystems can be less affected. So, for instance, the contamination of underwater water will be reduced because chemicals will not be needed for doing that. And at the end, you can produce food without depleting the soil. So, because at the end, we need to keep that balance.
Yeah, definitely. Yeah, agricultural robotics is something I'm quite excited about for a lot of the reasons you've just outlined. But you often see agricultural robots being developed very much for one task. So I guess the vision would be to have one agricultural robot that can kind of do many different tasks within its repertoire.
Yes, and that again is a problem of adaptability because we need more versatile design that can work on the field, for instance. Normally, we have a lot of robots in indoors where they can, for instance, harvest the strawberries and do several specific tasks. But if you use the same robots outside, because of the changing terrain conditions, the weather conditions as well, you cannot use them.
Yeah.
And that's why I think it's key to learn from nature how to enhance that adaptability. And I believe that this new trend also has emerged in the last decade is because of the advance in other areas, such as 3D printing, for instance. Because before, for doing the hoof that I was mentioning, it was complicated to generate the mold itself.
Yeah.
Now I just make my design and I just 3D printed. Is maximum, depending on the type of printer you use, in a day it's done. And you can print several of them without so much hassle. And I think because of these technologies that are also improving, are allowing us to improve also the body of the robot.
Yeah.
And other area also is smart materials. There is these materials which are soft, and depending on the type of characteristics that they have, they can be used as sensors, they can be used as an actuator. They have several applications as well. So something that I like actually about robotics, or why I am doing this type of research, is the versatility that is needed in this type of research. As a roboticist, you don't work alone. You work with material scientists. Depending on the field of application, you work with clinicians, or you can work with farmers, or you can work also with industrials. And the same, you can also work with end users, like just the normal public.
Yeah.
Because let's use the example of the fingertip interface. If we have a fingertip interface that can be used to provide a more vivid feedback, at the end we can enhance our video calls. Because now, because we have this just 2-dimensional screen, and there is not that interaction, so we get bored. So it's not the same. So if we add the touch feedback, actually we have a more realistic interaction.
Yeah.
So I wonder if that also will enhance that social bonding that it is decreasing because of this lack of contact that we have.
Yeah.
So that is another example of why I like about robotics. It allows you to work with several fields. It can be applied in several fields.
Yeah. I'm wondering as well if you could apply the fingertip haptic feedback thing to like gaming, like video games. It could make for a much more immersive experience.
Exactly. That is true. Actually, the original purpose of why it was developed, it was for minimal invasive surgery, because now those the robotic systems, they don't have touch feedback to the surgeons, so they cannot use the information that before they had access to in order to understand what type of tissue they are working with.
Yeah.
So that was the original idea. But now, because it is something so fundamental, it actually has evolved to several areas. So now we're using the same fingertip interface to be used as a diagnostic tool in order to understand the loss of touch, because depending on the age or other conditions, humans tend to lose the sense of touch.
Okay.
But so far, there is no technology to measure it in an accurate way. And with this fingertip interface that was originally developed for other purpose, we realized we can use it as well for this type of application.
Yeah, I love it when that happens. It seems to happen quite a lot in robotics, where one thing invented for a particular purpose kind of just turns out to be immensely useful in so many different areas. Sara, it's been fascinating talking to you today. I've been speaking to Sara Adela Abad Guaman, an assistant professor in robotics control and autonomous systems at University College London. Thanks, Sara.
Thank you very much.
Artificial intelligence is a topic we've touched on time and time again in Robot Talk, because in many cases it is the brains that brings robots to life. If you'd like to hear more about this new world of AI we're living in, I recommend checking out the Living with AI podcast. And I'm here with the producer and host, Sean Riley, to find out more. Hi, Sean. Thanks so much for joining me.
Hi. It's so nice to kind of have a chat and be on somebody else's podcast. Yeah, no, Living with AI's, it's been going for 3 seasons and we've got plenty of episodes for you to binge on. But basically, it's looking at this idea of trustworthiness and AI. So how can we, should we trust AI, and what are people doing to make it something that we should be able to trust, I suppose?
Fantastic. So what kind of format do you follow? Is each episode a different topic, or?
Yeah, well, a good point. We kind of have different umbrella topics in each episode, but the way it works is we have 2 sort of ways of doing it. One might be a feature interview with somebody who's perhaps a researcher in logistics, and they're looking at how AI impacts logistics or supply chains. And then we often have a panel of people who will discuss that off the back of it. So we'll have some research from various different, usually academic institutions, often somebody from industry. So we've done all sorts of things from AI in the military, supply chains, as I've just mentioned, robots. We've talked to people working in the kind of west coast of the USA doing startups in AI and all sorts of things. And then the other type of thing we do is a project episode where we talk about some funded projects that the TAS Hub, the Trustworthy Autonomous Systems Hub, which is a UK institution or network, projects they've funded and what they've been doing, what research they've had, and everything from care homes and health through to, some really cutting edge stuff.
Brilliant. Yeah. It's nice to hear that you cover such a broad range of topics like we do on Robot Talk. So where can people find the podcast?
Well, we're on most of the podcast providers. So, Apple Podcasts, Google Podcasts, all those sort of places, Spotify, wherever you want to find us. So if you're able to pop a link in the show notes and people will be able to kind of jump on us. But we're hosted on Buzzsprout. So there's a Buzzsprout page you can go to, which is probably the easiest way to find us.
Absolutely. Great chatting to you, Sean.
Thank you so much.
Thanks for listening. If you enjoy Robot Talk, please do share the podcast, subscribe, and leave a review to let us know what you think. And make sure you check out our social media channels to see a photo of the goat hoof-inspired robot foot that Sara and I talked about. We're at Robot Talk Pod on all the socials. Next week, I'll be speaking to Guillaume Doisy from Dexori, all about autonomous warehouse robots, mobile robotics, and software. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.